Hello everybody. In this section we're going to be finding special limits, or limits of functions that are unique, can't be solved by substitution or algebraic simplification. Case in point, this first one, we're taking the limit as x approaches 0 of sine of x over x. Now this is the quintessential special limit. Notice substitution doesn't work. We'd get sine of 0 over 0, which is 0 over 0, indeterminate form. That doesn't work. There's no way to simplify this. The x's do not cancel. The only way to deal with it is to look at the graph. If we were to graph y equals sine of x over x, notice the y value as we get close to 0 is 1. Now there is an open circle here. The graph is not showing that, but this limit is 1. Okay, we're going to apply this to another example here. Limit as x approaches 0 of 1 over x cosecant x gives us 1 over 0 if we try substitution. But let's apply what we know about cosecant. It can be rewritten as sine of x. 1 over cosecant is sine of x over 1. So, because of that trig identity, I can rewrite this. Sine of x is the numerator, x is in the denominator, and we are taking the limit as x approaches 0, and we can see from our previous example this is going to be 1. Alright, let's try again, a little bit different one. This is 3x squared plus 5 cosine x minus 5 over 2x. Very complicated. Substitution doesn't work, gives us a 0 in the denominator. There's no immediate way to simplify this, but we are going to be given an identity, so to speak. We are being told that the limit as x approaches 0 of 1 minus cosine x over x equals 0. So we're going to modify this algebraically to see if we can get it to work. I'm going to take 3x squared and put it over 2x, and then we'll break up the other parts. 5 cosine x minus 5, all that will be over a separate fraction, 2x. Okay, just properties of fractions allow us to do this. Now we see this second part here is starting to look like 1 minus cosine x over x, at least have the general shape. This first fraction will simplify easily enough. 3 halves x. Alright, now in order to get this to look more like our identity, I'm going to first factor out a negative 1. Let's put a negative 1 out there. Now what that does is it'll change the signs in either the numerator or the denominator, not both. We'll leave the denominator intact. Alright, and then this positive 5 cosine x becomes a negative. The negative 5 becomes a positive. And not only that, I'm going to switch the order. I'm going to write 5 first, and then minus 5 cosine x. Alright, we're getting there. We're going to factor out a 5 halves from this second term, a 5 in the numerator, 2 in the denominator. And as you can see, we'll have 1 minus cosine x all over x. Still have our 3 halves x on the left here. Alright, and as you can see, this matches our identity perfectly. Keep in mind we are still taking the limit as x approaches 0. Substitution will work just fine on this first one. We know this becomes 0. And we're not really using substitution, we're using more of the identity that was given to us for the special limit. So 5 halves times this value will be 0. Okay, and simplifying this down, we know that this limit will equal 0. Okay, so there's a few examples of special limits.